Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see today's problem, predecessor and successor. You are giving a root of the BST and an integer key. You need to find the first in-order predecessor and successor of the given key. If either predecessor or successor is not found, then set it to null. The in-order traversal of a number is just smaller than the target is the predecessor, and the number just greater than a successor than its target is successor. So in this question we are giving a binary search tree. So binary search tree is a tree where the root node's value is less than the left child node's value is less than the right child value and greater than the left child value. So in this question we are giving a key and the BST. We need to find the predecessor and successor. So predecessor is a node which have value just less than this value the node's value, and a successor for any node is the value which is a node which contains the value just greater than the node value. So in this question we are giving a key. We need to find its predecessor, which means we need to find the nodes which is closest but smallest to this value, and successor which is closest but greater than this value. So we know a property of a binary search tree that the in-order traversal of this of the binary search tree is in sorted order. So we will use this property to traverse the tree and find the predecessor and successor. Now let's look at the code here. So people define predecessor as and successor as null pointer, because in the question we are giving if no predecessor or successor, then set it to null. And then we will call the solve function, which will be the in-order traversal of this tree. So we will pass predecessor and successor by call by reference, because we want to change the value for every call. So if the node is null pointer, we will return false, and we will simply call for the left subtree. And then if we are returning the value from true boolean value from the solve function, the true value indicates that we have find a predecessor as well as successor, and we will return from that. So if we find the predecessor and successor in the left subtree, we don't need to traverse the right subtree, so we will simply return from that moment onwards. If not, we will check if the node's value is less than the current key. If the current node's value is less than the key, it means it is a candidate for the predecessor, and we will set it to the node, because, and we are also sure that the predecessor is set correctly, because we are traversing the tree in order fashion. In order fashion, it is in the sorted manner. So whenever this value holds, we are closing towards the key value from the leftward direction. So this condition, if this condition holds, the predecessor will be the current node. Else, if the node value is greater than the key, it means we have found the first key which is greater than first node which is greater than this key. So this is the successor, and then we're gonna return true, because we have found predecessor and successor, and we are gonna return true. So and if the current nodes, if these condition doesn't hold, we are gonna traverse the right subtree. So guys, if you find this, in the time complexity will be big O of n, and space complexity will be big O of 1, because we are only using two variables here. So guys, if you find this video helpful, please like this video and subscribe to this channel. It means a lot. Thank you.